I will go ahead and add a few more points here that are kind of tangentially related to the whole idea of emissions from the food system and trying to reduce the emissions by cutting down waste, the supply chain, and so on and so forth. Just as a bit of information, greenhouse, we have been looking at emissions from food systems, and beef and lamb and prawn and cheese, they have different positions depending on what you look at in terms of per calorie per kilogram, per protein kilogram, or whatever else. Here we are just looking at contributions of methane in addition to greenhouse gas emissions, other greenhouse non-methane greenhouse gases, just for our own edification, again, to see how things change. So beef herd and beef on average still come out on top when you look at methane emission. So greenhouse gas emissions excluding methane and emissions from methane. We know that methane is a big part of the livestock production system. Beef on average, and then you have here, surprisingly, lamb and goat. They jump out with more methane than non-methane greenhouse gases. The same for cheese. Well, cheese has almost the same, 13 to 24. Rice, you expect to have much more methane because of the flood irrigation. So now there are newer methods to change that. If you look at greenhouse gas emissions from protein-rich foods instead of just ranking them, then you have short versus long-lived greenhouse gases. So CO2, of course, is a very long-lived greenhouse gas. N2O is the same. But methane has a residence time of about a decade. So here, beef herd and beef average come up on top. Also, when you rank for protein-rich foods, but then you get prawns, beef for dairy, lamb and goat, cheese, and so on down here. So the rankings change a little, but the main point I wanted to make is that the methane contributions from the food systems are pretty significant as well. This is a paper that looks at the resilience of the supply chain, food supply chain across the globe. And resilience is basically the ability to recover from any kind of perturbation, right? So where do the perturbations come from? So you have environmental variability, economic influences, the supply chain itself, which includes production, storage, and processing, distribution, retail and markets, and consumption. And then you have cascading effects into the system. So there are arrows up and down here, which I'm not going to go into details, but I wanted to just say that there is plenty of room in the global food supply chain. By increasing its resilience, one can reduce waste, for example, and remember we get almost 6% of the food system emissions from waste. So anything we can do to reduce waste is always good. And you have co-benefits like food security and food availability, prices, and equity, access, and so on and so forth, right? So environmental variabilities range during the production from algal blooms, coral bleaching for fisheries, crop and animal diseases, droughts, extreme temperatures, rainfall, floods, pests, and so on. Excuse me. Economic influences include commodity prices and input supply access, and they can cascade into agricultural income, crop switching, fallowing, income diversification, and such. So you have lots of other things here in the storage and processing part of the supply chain. So you can again see natural hazards, pests, food prices, storage capacity, and then cascading into agricultural income, food safety, processing, source switching, spoilage, use of stored food, and so on. For distribution, you have extreme temperatures, floods, natural hazards, wildfires, affecting fuel prices, food prices, transport network, and tariffs, cascading again into market access in addition to the previous ones. For the retail and markets, similarly, climate hazards are important, economic influences are important, and cascades into portion sizes, price volatility, food substitution, spoilage, food shortages, and so on. Finally, at the consumption end, again, you have extreme temperatures, floods, seasonality, and natural hazards. Places that are influenced by monsoons, for example, are facing this every single year now. Food safety standards. So in the economic influences, you have factors like food safety standards, food taxes, transport network, and then cascading into foodborne diseases, substitution, energy, nutrient uptake, so nutrition security, physical and economic access, processed food, spoilage, and so on and so forth. And there are some ideas proposed to look at the feedbacks in terms of direct link between production and consumption in subsistence farming, and you have private sector influence over production. So you can go 1, 2, 3, 4, I guess. So let's start here. Private sector influence over production. We're going to have a feedback between retail markets and production. Limited consumer influence over production decisions from consumption to production. Vertical integration of food corporations affecting storage, processing, distribution, retail markets. You have this direct link between production and consumption here, going from production to consumption for subsistence farming. Vertical integrations of smallholder farmers and fishers, and subsistence farmers are net purchasers of food in the big picture. So this basically looks at the resilience of the food supply chain. The next paper looks and proposes that making food as a system, thinking of food system as a part of the global system, can improve its management policies and its role in adaptation and mitigation to climate change. Okay, so details are there. I'm not going to go into it. I just want to give you pointers to these papers and make the most salient points out of them. So this is comparing 2017 to 2016 mean values and standard deviations of emissions from AFOLU, which is agriculture, forestry, and other land uses, and the global food system emissions by component, including food loss and waste. So agriculture, forestry, and other land use, pre to post production and total. So this is from AFOLU, 12 gigaton CO2 equivalent per year. Percentage of anthropogenic greenhouse gas emissions 18 to 29. If you treat it as a food system, then emissions from the same things here, 10.8 to 19.1 gigaton CO2 equivalent per year, and the percentage is 21 to 37. Okay, so what does it give you? It basically tells you that taking the whole system, including the supply chain, production to consumption, storage, processing, transportation, etc., is going to give us a better handle on tracking the total emissions. Food system supply side and demand side technical and economic mitigation potentials. So now you treat this whole thing as food system. Mitigation potential in the supply side and demand side from technical and economic mitigation potentials in gigaton CO2 equivalent per year. You can see the numbers. There is a large range here, 2.3 to 9.6, 0.7 to 0.8 on the supply and demand side respectively. From the economic potential, 1.5 to 4 gigaton CO2 equivalent per year, and demand side 1.8 to 3.4 gigaton CO2 equivalent per year. So obviously there are various options, and you can look at the options this way: mitigation, adaptation, and co-benefits of food system responses. Colors indicate different levels of synergy between mitigation and adaptation to climate change associated with each food system response. So I've been looking at ways to reduce emissions from food systems, which tells you about mitigation potential. Adaptation can be made part of it by treating food system instead of separating it into sectors, kind of foods, proteins rich versus environmental impact, water impact, greenhouse gas emissions, non-methane, methane, etc., etc. The food system can allow you to do this together, and the mitigation and adaptation potential either have no synergy, limited synergy, high synergy, or very high synergy. And there are a number of items listed under several categories. Here is improved crop management. So now food system brings that part as well, which includes adaptation and mitigation. Food system response is to increase soil organic matter content. So co-benefits include livelihoods and biodiversity. I won't go through each of them. You can look at the table from the paper. Change in crop variety, improved water management, adjustment of planting dates, precision fertilizer management, integrated pest management, counter-season crop production, biochar application, agroforestry, changing monoculture to crop diversification, changes in cropping area, land rehabilitation, tillage, crop establishment, residue management, crop livestock system. So now you see that this is a very different way of looking at things. You can do improved livestock management as well with various approaches, silvopastoral systems, new livestock breeds, methane inhibitors, thermal stress control, seasonal food supplementation, improved animal health, parasite control with various co-benefits. In the sector of improved food supply chain, which we just looked at, and climate services, we have early warning systems, planning and prediction for seasonal to intra-seasonal climate risk, reduced food loss, urban and peri-urban agriculture, bioenergy, for example, from energy waste. So gives you a range of examples in each sector of the food system. Finally, demand management includes dietary change, which have high co-benefits of health as well as synergy between adaptation and mitigation, reduced food waste, packaging reductions, new ways of marketing, for example, direct sales, transparency of food chains and external costs. So here you have health, water and energy, pollution, livelihoods and energy, health, energy and water. So these synergies are very critical, and they can be tracked if we take food system as one instead of separating it into land use, water use, fertilizer use, greenhouse gas emissions, supply chains, adaptation requirements, crop yields under climate change. So you can split it into so many pieces, but in this case you are putting it all together, and it should allow you to better track food systems role in adaptation and mitigation. So response to climate change as well as mitigating climate impacts, including emissions reductions from the food system, which includes production, transportation, processing, supply chains and so on. Okay, that's a good paper. I think you should read it.